Hi guys, welcome to this chemistry session. Today we are going to learn about the Kolbe's reaction. So let us see what is Kolbe's reaction. Kolbe's reaction is basically a reaction of phenol where we are going to form salicylic acid from phenol, right? So the general reaction goes in this way. We are going to take phenol, right? Then we are going to use carbon dioxide at a temperature of 120 to 140 degrees Celsius and an atmospheric pressure of 5 to 7, and in an alkali medium we are going to use sodium hydroxide, or you may use potassium hydroxide also. We are going to get salicylic acid, right? One thing about salicylic acid is acts as a precursor molecule for the formation of aspirin. Aspirin, you know, it is a tablet, medical tablet, right? So it is used as a precursor for aspirin. So it's precursor meaning it's the basic compound from which we are going to derive, or from which we are going to prepare aspirin. There are two steps while performing this Kolbe's reaction. Namely, first we are going to use phenol and react it with sodium hydroxide, right? So this OH will be ionized in the form of O minus H plus. Since it is a covalent bond, due to the difference in the electronegativity, we are going to have some sort of polarity in the bond, right? And NaOH dissociates into Na plus OH minus. So this OH minus will take away H plus, and this O minus will take away Na plus. So resulting in the formation of O minus Na plus, leaving group will be water, right? This is called as sodium phenoxide. This is called as sodium phenoxide, and this is phenol. This is the first step. Second step is we are going to take this sodium phenoxide and going to react it with carbon dioxide. Carbon dioxide acts as an electrophile in this reaction. So we can tell that Kolbe's reaction is also a type of ESR, that is electrophilic substitution reaction. That is, we are going to substitute electrophile in this benzene aromatic nucleus at the ortho position. So we can term it as electrophilic substitution reaction. So as I basically mentioned about the temperature of 120 degree to 140 degree and a pressure of 5 to 7 atmosphere, we are going to get benzoic as salicylic acid, right? Salicylic acid. This carbon dioxide is substituted at ortho position. So this is the steps involved in Kolbe's reaction. Now let us go to the mechanism. Mechanism of Kolbe's reaction is very simple. So let us see how the Kolbe's reaction works out, right? So this is the mechanism where we are going to use. So already in the first step we got sodium phenoxide, right? Plus. And now I am going to use carbon dioxide. We know carbon dioxide can be written as in this form, right? So this will satisfy the valency of carbon, tetravalent. right? And we are going to have the lone pair over oxygen. Now, since oxygen is having more electronegativity than carbon, one of the bond will shift towards oxygen, leading to the formation of positive charge on carbon and a negative charge on oxygen, basically leading to the formation of an electrophilic species. So here we are going to observe an electrophile. This is what I was talking about, that carbon dioxide acts as an electrophile in this Kolbe's reaction. So this is electrophile. Okay, so I am going to use that electrophile in this reaction. This is a positive charge. Now observe here, if I write a resonance structure of this, for your better understanding, so let this be O minus. For timing, let me neglect this Na plus, so I will take O minus, right? So this is the bond we are having, positions of pi bond. So this oxygen will give out its electron here, and this bond will shift on this carbon, right? And what is the result we are going to observe? We are going to see a double bond on here on this carbon, and we are going to electron, and this is the structure we are going to electron rich center at ortho position. So this structure, when I am going to react with this electrophile, this carbon, which is rich in electrons, will attack the carbon, leading to the formation of remember, every carbon in benzene is having a hydrogen attached to it, right? This is very important. Here we are going to have hydrogen. We don't usually show it, but we do have a hydrogen over here. When it is, thus it is called C6H6 benzene, right? So we do have a hydrogen, but we don't show it. When I am going to take away this carbon here, let me write as it is, O minus. This hydrogen is needed to be shown in this way, right? This is going to be the hydrogen. So here the valency of all the carbons is satisfied. This bond remains as it is. Now, see here, if you look at this structure, it is having 4 pi electrons. In our previous videos, we have seen, in one of my video, I have told you that when I was doing about the Haeckel's rule, I told you that 2, 6, 10, 14 and so on, 4n plus 2 pi electrons. If any aromatic ring is having this many number of pi electrons, then that aromatic ring, then that structure will be called as aromatic. But here, see, if I do have one aromatic ring here, one ring, so let me put it, n 4n plus 1, so it's 4 plus 2 is 6, 6 pi electrons. Am I having 6 pi electrons? No, I am having 2 plus 2, 4. So I am short with 2 pi electrons. So what this hydrogen will do is, it will just give away its electron here. Since this hydrogen is giving electron here, this bond is going to shift, and here I am going to get the electron on hydrogen. At the same time, if this bond goes to hydrogen, the electron, then oxygen will be having negative charge, right? It will be somewhat like this. This negative charge, here I have hydrogen and carbon dioxide, everything, right? This negative charge will be taken away by this hydrogen. I am talking about like this. So this will become OH here, and carbon dioxide as it is no change with it, and this is going to be the structure. So this is what I got here. Now we are almost coming to the end of this reaction. What product I got, let me just write it here. Okay, so this is going to be the OH, and this is the double bond, this is minus sign. What I'm going to do, I'm going to acidify. I'm going to use sulfuric acid. So I'm going to form the acidification. If I do acidification, so this will break into H plus HSO4 minus, right? This is going to dissociate into this form, and this negative charge of oxygen will take away this hydrogen, leading to the formation of OH. Now look at this. This is what we require, salicylic acid. This is salicylic acid. The IUPAC name of this is, let me name it. So here carboxylic acid and phenol alcohol. We have two functional groups. What I'm going to do is, when we look at the priority group of functional groups in IUPAC nomenclature, we do observe that the carboxylic acid group will be having more priority rather than alcohol. Thus, I'm going to give numbering as 1 for carboxylic acid and 2 for this particular OH group, and 3, 4, 5, 6. Not necessary, but I'm going to give here. So according to this, I'm going to have hydroxy. See, OH group, if it is used at the suffix of any name of a compound, then we use OL, right? For alcohol, we use OL as a suffix. But if the same OH group is used as a prefix of any compound, then we are going to use it as hydroxy, right? So this will be 2-hydroxy. What next? So it's just leave this. What we are going to have? We just have here structure COOH. What it is? It is nothing but benzoic acid. 2-hydroxy benzoic acid. Since if there is any carboxylic acid group, then the suffix of that carboxylic acid group in IUPAC nomenclature is denoted as OIC, oic acid, right? So we are going to use benzoic acid. So this is the IUPAC nomenclature. This is the common name, and this is this salicylic acid. As I already mentioned initially in this video, that it acts as a precursor molecule for preparation of aspirin. So this is all about salicylic acid, right? Preparation of salicylic acid from phenol, and this is what is Kolbe's reaction. So whatever we have learned in this video is that we took initially, so we are going to prepare salicylic acid from phenol by in a NaOH medium, that is basic medium, NaOH conditions, at a temperature of about 120 to 140 degrees Celsius and at an atmospheric pressure of 5 to 7. And later part of the reaction, we are going to even do acidification, right? This is all about the Kolbe's reaction. Guys, I hope you have understood the topic and the reaction. If you have any doubt, please do comment in the comment box below. Thank you.